So I was doing some straightening up and getting rid of and parting out some old test equipment, radio chassis and whatnot. Gutted out a couple old oscilloscopes and two old WaveTech signal generators, and just going through stuff I don't need anymore. It's stuff that I had mainly bought for parts or the cabinets. And I ran across this guy and I was like, why do I still have this? You know, I probably picked it up in an auction somewhere in a lot, because a lot of times I'll go to, you know, old radio TV repair shops like my grandfather and uncle used to have back in the day. You know, have been out of business for years, and you'll go to a public auction where, you know, a family's settling an estate of a shop that's been closed for, you know, like maybe 20 years or something. A lot of times I go to auctions like that. You can buy entire shelving units of test equipment for pennies on the dollar, or, you know, sometimes pennies per piece of equipment. And that's probably where I picked this up. But yeah, at first I looked at it, I was like, why did I keep this? Kind of old and clunky looking. Does come with the probe, so, you know, there was an advantage there. It came with the factory original probe. But yeah, I looked at it, I was like, man, why do I have this? I don't understand why I kept it. Maybe time. I didn't have time to dismantle it for parts. Because, you know, I'd take something like this. There's nothing I really need off of it. I'd keep the knobs, recycle the aluminum chassis. Electronics components would go for electronics recycling, and yeah, that's about it. But then I actually got to looking at it, and I plugged it in, and I saw why I kept it. It's got a VFD display. So that stands for vacuum fluorescent display. So yeah, it has a really cool looking display. And what those are, now I don't have the exact kind that are in here, but I have almost the exact part number displays that are in here. Again, Lord only knows where these came from. But I got a bunch of these displays. These are new old stock. But this is a vacuum fluorescent display. So this one actually has two displays. So these two digits here are one display module, and they're 7-segment displays. And then this first display module here is actually a 0. Actually, it's that, minus this last digit. It has the positive, minus signs, a 1, and a 7-segment display. But they're glass. I don't know if you can hear that. And they're called vacuum fluorescent because it is. There's the vacuum where they drew these into a vacuum. But yeah, so it has that cool look. And the more I got to thinking about it, I got to think, well, you know, actually this might be a good meter for the upcoming electronics course I'm going to be doing. Because a problem I run into when I'm doing videos sometimes when I want to show voltage, I'm using a brand new style meter with an LCD display. That thing just blinds this camera. I mean, it's just, whoop, here, I'll turn it on and show you. Wait for it to boot up. Yeah, it says Rigel DM3000 series digital multimeter on there. You can't see any of that. Now it's showing a voltage measurement. You can't see that either. It's just a blindingly bright white. And no matter how close I get to it, you just can't read that. Now I can, where the heck is that? Utility, system, display, invert. So there, if I invert it, yeah, you can see it. But even if I pull the camera back, it's still so bright. Yeah, I can turn the, you know, probably play around with the contrast and the brightness, but that's really not going to work that great for that video series I'm going to be doing on, you know, electronics. Besides that, the digits are smaller. Now, I kept this meter up here. I like this one. It's LED display. Main reason I have this one is this one actually does higher resistance measurements than even this, you know, modern higher end meter. But, you know, that has nice visible display. But I think, honestly, of the three, I don't know if I can get back far enough to get all three in view. Yeah, there we go. I think the orange looks best. Yeah, I really think I like the orange on camera, you know. And I want to show that, honestly, for repairing, doing the type of repairs I do here, honestly, this is really all you need is something like that. It doesn't even need to be digital. Shoot, you can use, yeah, I've got vacuum tube voltmeters for a reason, extremely high input impedance. And that's one of the downfalls of some meters is they have a low input impedance. The problem with low input impedance meters are when you probe the circuit, the meter loads down that circuit and the reading will change because the meter is sinking a lot of power away from the circuit. This is actually a high input impedance meter. This has a 10 mega ohm input impedance. And then also, if you're having problems with like capacitive coupling and whatnot with, all this wire and the probe and everything's making, that's actually why this has this special probe. This is not like a demodulator probe like you'd see on some equipment. This has a direct and a 100K position. So there's 100K ohm. Actually, that's actually very, very far out of spec. I actually measured it. It's like 150K is what it's measuring. But when you flick this switch into the 100K position, it adds an additional 100K of resistance in series with the meter's 10 mega ohm input divider circuit input impedance. So you end up with 10,100,000 ohm input impedance. But the reason they did it at the probe tip here is that 100K resistor is now applied right here at the tip of the probe. So it helps with decoupling and whatnot. And now that does throw the accuracy of the meter off, but they actually even have that in the manual here. And that's another reason, oh man, I definitely got to keep this. Comes with the original manual, parts list, schematic, all the original paperwork. We got, even it's tested up to 1500 volts. Shoot, that's even, I didn't actually look through here. Yeah, that's the original Cal certificate. 2/11/1976, back when this thing was calibrated at the factory. But yeah, it has all the original paperwork. But yeah, the probe. Yeah. So when the probe resistor is used, the reading error of -1% is introduced because the 100K resistor value is placed in series with the internal 10 mega ohm divider, like I was saying. If this error is considered significant, the correction can be made to the reading obtained by increasing the value of the observed reading by 1%. So, whatever your... But like I say, the main thing is, and actually they even describe it here about the probe, this probe is provided with a selectable 100K resistor, which is used when performing DC measurements in high impedance or high frequency circuits. The resistor isolates the cable and the input capacity of the meter from the circuit in which the measurement is being performed. This reduces capacitive loading, which may result in erroneous readings. So, yeah, it's nice that it came with the original probe. Now, the probe needs a little bit of help. Actually, not the probe, but the wire. You can see that's the original molded BK end. But yeah, the coax, the shield is kind of all frayed out. I haven't even checked to see if that shield is actually attached to the ground or not, or if they just had that around there. But it works. As you can see, the meter turns on. And the vacuum fluorescent displays, like I said, I just think that's really cool. Now this does have a 0 adjustment on here, and actually that's used in all modes and all ranges. So the manual procedure for using this meter would be, if you're going to measure DC volts in this range, what you do is now the ground clip is missing off of the ground wire here, but no biggie, we can just hold that together. What you would do is just hold that like that. You see how the negative sign is blinking there? That's what you want to adjust for. If you have it too far one direction, you get the minus sign all the time. Too far in the other direction, it just stays off. 0 is right where it's blinking. You're hovering right at dead 0 right there. So, and it works. It's actually accurate too. And I haven't done anything to this meter. Actually, let's leave it propped up. I have the top and bottom covers off actually so you can see the inside here in a second. This camera up here. And I actually have a DC power supply turned up. Oh, we get in the hole. Come on, camera. Push this back a little farther. We'll just stick that in there so it's applied to about a 13.9 volt power supply. And look at that, 13.91 volts. So, and actually we can even, so you can see it's reading 13.91. Let's see what it actually is. Since that meter there is already turned on. 13.8648 volts. So it's actually really close. Really, really close. So, I mean, it does need to be calibrated, which I'll do. Like I said, I was going to junk this thing when I first saw it, but yeah, as soon as I saw that, I just have, I don't know what it is about VFD displays. I just really like them. They're so easy on the eyes. I've got so many frequency counters. I've finally gone back to using a leader over here, again, for the same reason. That one has a green VFD display. Actually, that's, how many digits is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. It actually has nine digits, but that's all one VFD module inside of that. Doesn't have multiples like this meter does. But yeah, so I think this will work fine for that electronics course. Digits are a little bit bigger. The camera seems to like that color and the intensity a lot better. And I want to show that, honestly, this is all you need for doing, repair work. My grandfather and my uncle back when they had a radio TV repair shop. This is the type of stuff you used to see back in the day in repair facilities. You don't need something like that. That's a 5.5 digit resolution meter. Or you can get 6.5 digit. You can get, insanely accurate meters that read out multiple decimal places. Honestly, people, for doing normal radio, television, consumer level electronic stereo systems, shoot, telephones and whatnot, you don't need all those decimal places. Honestly, for radios, that's all you need right there. You need basically 1 decimal point for most cases. The second decimal point, yeah, it's nice to have, but yet, honestly, that's a lot of times that's all you need. The tenths. Hundredths is nice. So, I think this will be fine, and I can show that once we get into the course, or even maybe once I get this thing, and I'm not going to do it right now, but when I restore this, I'm going to recap it and calibrate it. I'll actually show that. Do an adjustment in a radio using this meter, do a measurement on that radio, then, whatever circuit I'm adjusting for, we can take, like receiver sensitivity measurement or something, and then do an adjustment using a high resolution meter like that, and I'll be able to show that it makes no difference. There's so many decimal places there that, quite honestly, it really doesn't make a bit of difference. And even they cool down, because those actually get hot in there. The way these work is, and you can actually, I've done this one time and it did work. You have to be careful. But the vacuum fluorescent displays, you can actually, if they start to get really dim, and actually when you look at the displays, in this one they're nice and shiny, kind of almost metallic, they'll start to get really, really dark. Well, it's getting oxides. They actually get hot. There's actually a filament in here, actually filaments, and they get hot. And a lot of times it's kind of like back in the old days, if anybody's familiar with picture tubes. I got lots of old picture tube testers for televisions, and they have a rejuvenate button, and that was meant to blast the carbon off the electron guns in a CRT tube. You can kind of do the same thing with these. You just have to be really, really careful doing it. What you do is you overvolt the filaments in this thing, and a lot of times you can cook some of that oxidation off. You just need to be really careful that you don't overdo it. But so let's see, meter is, get her unplugged here. And I can show you the inside of it. So yeah, there's not a lot to it. Bottom cover just pops off. 3 screws hold that on. 2 screws in the top cover. Yeah, look at that, mint condition. Only has 2 screws along the back side that hold that on. You're probably looking in here and thinking, oh man, that's a nice solid state, pretty fancy looking meter. Honestly, that's not the meter. This is the meter. This area here is the power supply. Pretty much everything you see here, that's all the driver circuitry for that VFD display. So they're just using a lot of 7400 series logic ICs. But yeah, pretty much everything in this area here is what's driving that display up front. So not an overcomplicated meter, and honestly, for the resolution that this meter has, that's all you need. You see easily accessible calibration points in this. Doesn't really have many electrolytic caps in it from the looks of it. 1, 2, 3, 4, 5. There's another axial lead one tucked way down in there. Yeah, so it's got 5 aluminum electrolytics, and these are the old style tantalum, so I'll change those 2 when I do it. It's got, what, 1, 2, like 3 tantalum capacitors. But, yeah, pretty straightforward, honestly. This thing will last for a really long time. That's one of the nice things about a meter like this. When something like this breaks, it's usually fairly easy to fix. It's not really that complicated. Something like that breaks, that can be a nightmare. Those are microprocessor controlled, and there's some parts that are in those things that, you know, especially once the manufacturers stop supporting parts, they'll just be unobtainium. Yeah, there's really not a lot in this thing that's, you know, unobtainium. When wafer sections go bad, a lot of times you can salvage a wafer section out of something else, and because these are just assembled, you can just take the nuts, take the screws out, disassemble them, and stick a wafer section in out of something, shoot, of a radio or a television or something else. You know, the ICs, they still make those today. There's really no parts in here, like I say, that, you know, can't be obtained, so a lot easier to service. And like I say, honestly, for the type of work that I do and for a lot of people do, that's really all you need. Something that you don't need the super fancy equipment. So, yep. In the future, I'll do a... Now, I'm probably not... I won't do a video of me actually recapping the blasted thing, but I might actually do another video at some point in the future of calibrating this. It's not really that difficult, and the alignment procedure is in the owner's manual over there. Though, actually... Well, that's interesting. If I'm not mistaken. I thought I saw more points in this manual here. Yeah, it's got 2 trimmer capacitors, C21 and 23. Yeah, there it is, C21 right there, and C23, and there's no parts in the holes. And they're not on the bottom of the board either. That's interesting. Maybe they decided they didn't need that. Yeah, actually they're not there. I was going to say capacitors, that would usually be, I guess, for the AC ranges, and yeah. Yeah, for 10 volt range, apply 10 volts RMS at 1 kilohertz. And adjust for 9.96 reading, and it's the same thing for the 100 volt range. I wonder why there's no trimmers in there. That's interesting. Just grab this CAL certificate. AC. It's only calibrated at the 1 volt range. Maybe there is a difference in this. I'm not seeing... Looks like somebody's done something to this at some point in time, because they've highlighted the gate and the sources on these FETs here. DC AC adjustment. There don't appear to be... wait a minute, right there. So they show them on the schematic. But it's in okay. This one's in parallel with another fixed capacitor. Now, they're not showing it in parallel with one there, but that would be in series with this other capacitor. So maybe, as long as it's within range, it doesn't need to be adjusted, and that's why they just don't have trimmer capacitors in here. And that'll be interesting once we actually get into, once I do the alignment on this, or the calibration, because it is in the manual. It's right there to adjust those two. So yeah, I'll have to play around with that. And I'm assuming if I can't get it calibrated, then all I'd need to do is, or if those are out of calibration, those sections, what did I say that was? C21 and 23. Yeah, they're 6 to 25 puff trimmer caps. Yeah, right there. 23, 24. Yeah, factory selected. So that's why they're not in here. Apparently, I guess it was okay at the factory when they did the alignment. They didn't need... they just did it with fixed capacitance. They didn't do it with adjustable. So yeah, factory selected. And you'll see that even in radios and television sometimes. Older CB radios. Now we're talking vacuum tube days or very early solid state. But a lot of times when you look at a schematic, you'll see a little asterisk. You know, when you're looking at your schematic here, you know, pick a part like a resistor or a capacitor, and you'll see a little asterisk. And when you look down in the legend, it'll say something like that. By the asterisk, it'll say factory selected or selected at time of alignment. So yeah, it may just not need them. So we'll have to see if I'm going to have to change any capacitance to bring this thing into calibration. But like I say, at least the DC voltage seems to be, it's within, what, 0.1, actually less, it's a little bit less than 0.1 of accuracy. So, but there you go. There's a preview of the B&K Precision Model 282 digital multimeter. And like I say, I'm pretty sure I'm going to just replace that meter right there with this one because I think the display will work out better for the upcoming video series. And besides that, then we'll be using something that I think a lot of people, not specifically this model meter, but you know, the type of equipment that, you know, if you want to follow along in the electronics course, the type of equipment that you'll probably have, because I don't expect people to be going out and buying, you know, high-end meters, you know, 5.5 or 6.5 or higher digit resolutions. I want to try and use in the videos, if I can, the same equipment that I'm going to recommend that you buy. I'm not going to recommend you buy this specific model meter, but I'll show that really all you need is the two decimal places will be all you need. So yeah, I'll try to, when I use equipment, I'm going to try in that course to use the same type and quality of equipment that you'll probably have yourself if you're going to follow along and do the hands-on portion. So there you go. Don't want to make this too long. I just wanted to show this cool meter with the cool VFD display.